So, good morning to all. Good morning to everybody. So, how are you all? I am from Vijayawada, man. Who is that? Where are you from? I think you are asking for your classmate. Yeah. Okay, great. Okay. Good morning. Good morning to everybody. Good morning. Mr. Shiva, switch off the chat box. Turn off the chat box. So, yeah, I'm fine. Now, listen to me carefully. Today, we have to discuss about further details of flower. Just we discussed few details in the last class. Chat box, stop using. Now, let us go further details of the flower. So, I told you in the last class what are essential organs, what are non-essential organs, and what are what is pedicel, peduncle, and what is thalamus, and what is bract. All those details we have discussed, right? Yeah. Now, let us discuss about position of ovary on the thalamus. Position of ovary on the thalamus. And look at the board carefully here. On the basis of position of ovary on the thalamus, we have three types of flowers. One is epigynous flowers. Epigynous flowers, the first one. Now this is epigynous flower. Sorry, first one is hypogynous flower. This is hypogynous flower. Next, perigynous flower and epigynous flowers. These are the three categories. Let us see about hypogynous flower. Listen to me carefully. In this case, ovary is present at the top. Look at the diagram carefully. Ovary is present at the top. Now this is ovary. And the remaining floral parts arises. The remaining floral parts are originating below the level of ovary. From where does they are originating? Below the level of ovary. That means here ovary position is said to be superior. And remaining floral parts position is said to be inferior. Remaining floral parts means calyx, corolla and androecium. Inferior to ovary. Whereas ovary is present at the top. Remaining floral parts are present below the level of ovary. This kind of flower is called hypogynous flower. So, hypogynous flowers possess what kind of ovary? Superior ovary. Got it? Is it clear for all of you? Now, the example for this hypogynous flower, you can take so many examples: China rose, mustard, datura, chilli, then tomato. So many examples you can give. Next, look at the board here. The next one is perigynous. Look at here. So, ovary is present in the center of the thalamus. Remaining floral parts originating from the margin of the thalamus. The remaining floral parts are originating from the margin of the thalamus. That means here the remaining floral parts are not coming below the level of ovary or above the level of ovary. So, this diagram is more clearer here. Now, this kind of ovary position is called half inferior. What is it called? Half inferior. Listen to me carefully. So, here ovary position is neither superior nor inferior, because the remaining floral parts are not coming from the base of ovary or not coming above the level of ovary. So here position of ovary is neither superior nor inferior, hence it is called off inferior, and such kind of flowers are called perigynous flowers. We have some examples for these perigynous flowers, like plum is one example, peach is another example. Now see the last one, epigynous flower. Look at the board. Look at the board carefully. Now this is the ovary. So here thalamus wall is completely fused with the ovary. Now this is thalamus. This thalamus and ovary wall both are completely fused, and the remaining floral parts are originating above the level of ovary. Look at here the board. Above the level of ovary. They are not present below the level, or not present exactly to the same level of the ovary. They are present above the level of ovary. That means here ovary position is said to be inferior, and remaining floral parts have superior condition. What about here? Ovary is superior, remaining floral parts are inferior. What about here? Ovary is inferior, remaining floral parts are superior. And what about here? Remaining floral parts are neither superior nor inferior to the ovary. Is it clear? For epigynous flowers also we have so many examples. One of the best example is, I think you are all known, that is cucumber, cucurbita, or that is pumpkin. And also you can take helianthus, that is sunflower. These are all some important examples for, this perigynous flowers, epigynous and epigynous flowers. Next, when it comes to, these are other examples for hypogynous condition. So you can very clearly see the ovary is superior and remaining floral parts coming from the below to the level of ovary. And this is the live example, like China rose, mustard, brinjal, chili, tomato, all these you can give. Now these are the examples for plum, peach, rose. Look at here. So here ovary is neither superior nor inferior. Now look at this epigynous flowers. So here ovary is inferior, remaining floral parts are superior. You can also take example like guava, cucumber, ray flares of sunflower. These are all some important examples. That's all. This is what you can see here. Next, when it comes to calyx, corolla and Androecium, Gynoecium. Calyx, they are the outermost whorl. You can also call them as accessory organs. Okay, and apart from that, they are non-essential sex organs. Corolla is also same, and of course there are so many variations you can find in calyx and corolla. Remember, in some cases all the sepals present in a flower, are free from each other. They are free from each other. Look at here, they are very free from each other. So they are free from each other like this. If they are free from each other, then such calyx are called, or such sepals are called polysepalous. What do you call them? Polysepalous. You can see here, they are not united, so they are polysepalous. Next, when it comes to, look at here, the sepals here are fused. You can see in this diagram, the sepals are fused here, here also same. Now this is gamosepalous. Datura is the best example for gamosepalous condition. So if sepals are free, it is polysepalous. If sepals are fused, it is gamosepalous. Similarly, even in petals also same thing you can find. If sepals are fused and petals are fused, gamopetalous. If petals are free, polypetalous. Okay, petals free in the sense like, look at the board. Look at the board. Say if you take hibiscus, China rose, all the petals are free from each other. This is polypetalous. Whereas in case of datura, all the petals are fused and appears like a funnel. This is gamopetalous. So this is what you can see here. Next, apart from this, mode of arrangement of petals or sepals. if you take petals or sepals, they will have a specific arrangement. Mode of arrangement of petals or sepals in relation to the other members of the same whorl is called estivation. What is it called? Estivation. So, for example, think that this is a flower. The flower will have a specific arrangement of sepals and petals. How can you observe the mode of arrangement of sepals or petals in a flower? When you take transverse section of the flower. If it is a flower, you have to take the transverse section. And if you want to see its symmetry, symmetry means whether the flower is actinomorphic or zygomorphic or asymmetric, you have to take vertical section. Be clear. This is longitudinal or vertical section. If you take the longitudinal section or vertical section, that will give you symmetry of the flower, whether it is actinomorphic or zygomorphic or asymmetric. If you take the transverse section, then it can help us to know estivation. What is estivation? Mode of arrangement of sepals or petals in a flower in relation to the other members of the same whorl. Look at the board. See here, all the sepals are arranged in such a way that there is no overlapping among them. See, this sepal or petal is not overlapping this. Similarly, this is not overlapping this. And look at here, this margin of sepal or petal is overlapping this. Similarly, this margin is overlapping this, this margin is overlapping this, this margin is overlapping this, this margin is overlapping this. And look at here, for one sepal or petal, two margins inside, one sepal or petal, two margins are outside, remaining three, one inside, one outside, one inside, outside. That means if you take the transverse section of your flower, you can observe all these details. Now this is called estivation. I am not going in the details of types of estivation, just I am giving you definition. Don't ask me what is evaluate, what is twisted and what is imbricate and vexillary. We will explain in detail by giving so many other aspects and also giving examples and interrelations. All these details you will be getting in our offline classes. Just remember definition of estivation. So what is estivation? Estivation is nothing but mode of arrangement of sepals or petals in the bud condition of a flower. That you have to remember. Once the flower is get open, you cannot find the estivation. Of course you can see, but it is difficult to identify the estivation. That's why if you want to observe estivation, it is must to take a bud of a flower. So in the bud, the arrangement of sepals and petals is very clear. And if you want to see this estivation, just you get one what is that, China rose flower, bud flower. Okay, it may be available in your street or in your kitchen garden. So get one bud and take a blade like a shaving blade and just take the transverse section at the bottom of the flower. Take the transverse section, you can check the arrangement of sepals and petals in that flower. You can do at your home. Today you try it and tell me tomorrow. Tomorrow in the sense in our next class. Okay, whether you have observed or not, and what kind of arrangement is there, that also you have to tell. In China rose you can do it, like whether the petals or sepals are overlapping or not overlapping, just tell me that. Can you do it? Can you do it by today? Yeah, do it and tell me in the next class. So this is about estivation. Next, when it comes to Androecium, let us go to the Androecium now. Androecium is composed of stamens. Androecium is made up of stamens. Okay, a stamen possesses, look at here, two components. One is filament, this is filament, and other one is anther. Look at the board. Now this is filament and this is anther. Similarly, this is filament and this is anther. So what are these? Anthers. And what is this? This is filament. So filament and anther, two things you can see in a stamen. And these anthers are again two kinds. Look at the board. I have given two lobes here. This is one lobe and other one, this is another lobe. There are two lobes in this anther. If there are two lobes in an anther, then such anthers are called dithecous anthers. What are they? Dithecous anthers. So what do you mean by dithecous anther? An anther with two lobes is dithecous. Understood? Don't ask me where are they present. I will tell you at the end. Okay? Just listen what I am explaining. Now look at this diagram. I have given the diagram where this anther has only one lobe. This anther has only one lobe. And if only one lobe is present, then it is called monothecous. Monothecous. Understood? Most of the students gets confused here by thinking that dithecous anthers are present in dicots, monothecous anthers are present in monocots. It is a false understanding. Understood? It is a false understanding. So dithecous anthers can be seen both in dicots and monocots. Monothecous anthers are also present in some dicots and some monocots. Got it? Is it clear for all of you? So dithecous means what? If anther has two lobes, it is called dithecous. If anther has only one lobe, it is called monothecous. Very simple. For example, you may ask me a question that what is the example for a dicot with monothecous anther? Yes, we have it. So many examples. China rose. You can check China rose flower where anther possesses only one lobe. Understood? Similarly, you can also find dithecous anthers in dicots. So dicots, most of the dicots have dithecous anthers. Some dicots have monothecous anthers. Dicots with dithecous anthers. So many examples we have. Like you can see in tomato, chilli, datura, bean. If I list like this, so many are there. Understood? Say monocots like rice, wheat, maize, lily, onion. These are all monocots, but they have dithecous anthers. Understood? Hibiscus is a dicot, but it has monothecous anthers. Do you know moringa? Drumstick, moringa. It is scientifically called moringa. It has monothecous anthers. Understood? So like that. So monothecous means what? Anther with one lobe. And dithecous anther with two lobes. And what is the function of this anther? Anther is the region where pollen grains are produced. So within the anther there is a microsporangium. You can check here. This is microsporangium. And within this microsporangium, the pollen grains are produced. Understood? The pollen grains are produced. Now another most important thing, there are also some cases where anthers do not produce pollen grains. Listen to me carefully. There are some species in which anther do not produce pollen grain. That means simply to say such stamens are sterile, that they are not useful for sexual reproduction, or they are not useful for fertilization process because they are unable to produce pollen grains. Such sterile stamens are called staminodes. What do you call them? Staminodes. So staminode is a sterile stamen. So what do you mean by sterile here? It cannot produce pollen grain. Got it? So So this is what you can see here. So this is what you can see with respect to the stamen. Next, when it comes to, you can see the stamens here. Now this is hibiscus flower. These are all monothecous anthers, and this is bean. In bean you can see diadelphus. Don't ask me all these details like monoadelphus, diadelphus. We will discuss about all these details in our offline classes. Okay, so let us go. Yeah, there is also variation in the length of stamens. Stamens will not have the same length. Like in a single flower, you can find the stamens with the different lengths. And I think you may ask once I open the chart box that example for staminode. Example for staminode is cassia. In cassia, there are 10 stamens are present. How many? 10. Out of the 10, 3 are staminodes, remaining 7 are fertile. 3 are staminodes. Staminode means sterile stamens, that they cannot produce pollen grain. Remaining 7 are fertile. So these are all some important things. Next, when it comes to the gynoecium, let us go into the details of gynoecium. Gynoecium is the female sex organ. This gynoecium you can also call it as pistil. Pistil is composed of carpels. I mean gynoecium is composed of carpels. Now each carpel contain a basal swollen ovary. Look at here, this is ovary. Swollen ovary. A median tube-like elongated structure called style. And terminal stigma. The tip of the style, stigma. These are the various regions of a flower, gynoecium. Now, if you take this stigma is the platform for landing of pollen grains. That means during the process of fertilization, pollen grains or process of sexual reproduction, the pollen grains will land on the stigma. Pollen grains that come from the anther will land on the stigma. Understood? And style is the median region, elongated tube-like structure, and this is basal swollen region itself is called as ovary. Inside the ovary, there is a cushion-like tissue. What is it present? Cushion-like tissue. Now this cushion-like tissue present inside the ovary, you can see here. I will just mark it with a yellow colored marker. Look at here. Now this is a cushion-like tissue present inside the ovary. Understood? Now this cushion-like tissue itself is called placenta. What is it called? Placenta. On the placenta, ovules originates. So ovules are present on the placenta. Where is it? Where is this placenta is present? Placenta is present inside the ovary. So what is placenta? Placenta is a cushion-like tissue present inside the ovary from which ovules originates. Is it clear? Is it clear? So ovule, you can also call it as megasporangium. What is the other name for ovule? So ovules are also called megasporangia or megasporangium. Inside the ovule, there is an embryo sac, and that contain a egg or female sex organ. Female gamete. Egg is present inside the embryo sac, and embryo sac is present inside the ovule. Say, for example, if you think that this is a ovule, just I am enlarging this segment like this. This is ovule. Okay. Now here there is an embryo sac, and inside the embryo sac there is egg. Now this is egg, and this whole structure is called embryo sac, and this structure is called ovule. So ovule is present inside the ovary, and ovule contain embryo sac. Embryo sac contain egg, which is female gamete. Is it clear? Yeah. Next, when it comes to the other details of this flower, look at the board carefully. There are some cases where, say, gynoecium may be composed of only one carpel or many carpels. If it has only one carpel, if gynoecium is composed of only one carpel, then it is called monocarpellary. There are also cases where more than one carpels will be present in a single gynoecium. That means two to many. If two to many carpels are present, in some cases all the carpels are fused, whereas in some other cases all the carpels are free from each other. Look at the board carefully. Look at the board. So if all the carpels are fused, then it is called syncarpus. What is it called? Syncarpus. S-Y-N. Syncarpus. Look at here. This is syncarpus. So all the carpels present in a gynoecium are fused and appears like a single ovary, single style, single stigma. Then it is called syncarpus. Say for example, let me give one best example. China rose, let us take. China rose, it contain 5 carpels. Gynoecium contain 5 carpels. But if you look, if you take the flower, if you observe the flower, you can see only one ovary and one style. Of course, there are 5 stigmas are there, but ovary and style, only one ovary, one style is present. Actually, how many carpels are present? 5. If there are 5 carpel, then there should be 5 ovaries, 5 styles and 5 stigmas in the flower. Because I told you, a carpel contain ovary, style, stigma. Every carpel contain its own ovary, style, stigma. Understood? But in hibiscus, what happened? All these 5 ovaries of 5 carpels are fused and becomes one ovary. All the 5 styles are fused and becomes one style. But stigmas are free there, like you can find 5 stigmas separately. Let us take another example to have more clarity about this. I think this plant may be available at your kitchen garden or nearby your houses. Take example as a tomato, or you can take chili, or you can take mustard, anything you can take. Take tomato. Tomato actually contain 2 carpels. It is bicarpellary. So if there are 2 carpels in the flower, then the flower must show how many ovaries? 2 ovaries. How many styles? 2 styles. How many stigmas? 2 stigmas. But if you look the flower, it contains 1 ovary, 1 style, 1 stigma. That means what happened here? All the 5 ovaries are fused, all the 5 styles are fused, all the 5 stigmas are also fused. So they are appearing like 1 ovary, 1 style, 1 stigma. This fusion among the carpels itself is called syncarpus. But there are also some cases where all the carpels are remain free. Like if you see the flower, you can found that many ovaries, many styles and many stigmas. Look at this diagram. Look at this diagram. See here, these are all the carpels. These are all the carpels in the center. So here all the carpels are free, and you can also take this lotus as example. In the center you can find many carpels. Every carpel will have its own ovary, own style, own stigma. Understood? Every carpel has its own ovary, style and stigma, and many carpels are present. That means here all the carpels are free from each other. This condition is called apocarpus gynoecium. What is the example? Lotus, rose, michaelia. There are so many examples are there. Just remember lotus and rose. So this is what you can see here. Next, and one more important thing is mode of arrangement of ovules on the placenta inside the ovary. What is it? Mode of arrangement of ovules on the placenta inside the ovary is called placentation. What is it called? Placentation. Look at here, the arrangement of ovules. This is ovule. Arrangement of ovules here and here is different, isn't it? It is different, entirely different. Here also very different. See, in every diagram we have different modes of arrangement of ovules. This mode of arrangement of ovules itself is called placentation. Don't get confused between placentation and estivation. Estivation is different. Estivation explains about mode of arrangement of sepals and petals, and here mode of arrangement of ovules. Okay, there are different types of placentations are also there: marginal, axial, parietal, precentral, basal. So you are going to know all these different types of placentation in our offline classes. Now it is not required. Okay, so this is about the flower. After fertilization, ovule becomes a seed. Ovule become a seed, and this ovary, see, this is ovule, right? This ovule become a seed, and this is ovary, and this ovary become a fruit. Ovary become a fruit and ovule become seed. When? After the fertilization. So this you have to remember. So I think time is almost completed. Only 5 minutes is left, because I took long time today because of to complete this flower topic, and we'll go with families from the Monday onwards. And now I am asking to open your chat box, and now you can start asking your doubts. Okay, so if you have any doubts you can ask me, otherwise you can simply leave the class. Okay, yeah, you can ask me now, like I'm waiting, so you can ask. Navadeep Kiranya, you are Kiranya. Okay, Chalapati Korra. Okay, now you can ask your doubts. If you have any doubts, you can clarify it now. First. Otherwise, I'll just close the session. Thank you, Koteshwar Rao. Yeah, one question has come. Karthik, sir, what is the difference between carpel and pistil? Yeah, both are same, man. Carpel is also called pistil. Both are same, carpel and pistil. Gynoecium is made up of carpels. In estivation, what are you asking? Charanya, you are something trying to ask. I am not able to understand. You type it completely, your question. What does placenta means? Placenta is a cushion-like tissue present inside the ovary from which ovules originates. Rida Mariam. Got it? Yeah. No doubts, sir. Okay, Sangeeta Rao. Good. That's great. Venshita, no doubt. Are you getting a daily practice test? I am sending every day to the administrators. Whether it is passed to you or not, I don't know. I am sending questions, like objective questions on whatever the topic now we are discussing every day on the class. So what happens if we cut the style directly and enter the pollen grains into the style? Okay. See, for germination of pollen grain, there are some chemicals present in the stigma. Unless otherwise these chemicals are there, pollen grain generally cannot germinate. So if you keep the pollen grain on the style directly, sometimes it fails to germinate. But there is also a method where pollen grain can be directly germinated on the style or ovary by doing some artificial methods, that is called intra-ovarian pollination. You are going to know in our second year syllabus, don't worry. Okay. Next, Jahnavi. There are multiple anthers in one flower. One of them is cut. Will the plant will be sterile? No. Sterile in the sense, Joshnavi, sterile in the sense the plant not able to produce pollen grain. There should not be any fertile stamens in that flower. Then the plant is called sterile. Okay. Yeah. Next, Can we purchase NCERT books now? Don't purchase it now. Next week I'll inform. Okay, next week. What is imbrication? I told you, no, don't ask me about different types of estivations now, because lot of details we need to discuss. Just I'm giving only definitions and outlines. Why shoe? Why shoe? Is it your name? Yeah. Chaitanya, sir, in the estivation imbricate, one perianth member is outside and one perianth completely inside, or twisted and then, sir, overlapping. Will have any direction? Yes. Every estivation type you are asking many doubts on estivation. I think you already studied in somewhere, so that's why you are getting these doubts. Every estivation has a specific mode of arrangement. There is also numerical representation. There is method of this arrangement can be represented by using numbers. Okay, so I am not complicating all those details, because many details are there in the estivation topic itself. Estivation topic itself takes 1 hour to discuss in our offline classes. Just 1 hour is required to discuss only that estivation topic. Placentation is discussed in 1 hour. Now all the details have discussed in just 50 minutes. Understood? So lot of things you are going to know. Don't worry, we will discuss about estivation and other details in our offline classes in detail. Where are you keeping the questions, sir? I am not keeping, I am just sending to the administrators. So I think they may send you. Karthik, sir, do staminodes have microsporangia? They may have microsporangia, but they do not produce pollen grains. Similarly, even in Gynoecium, there are some cases where ovary is present but ovules are absent. That means it is sterile Gynoecium. Such sterile Gynoecium is called pistillode. What is sterile stamen? Staminode. Sterile Gynoecium, pistillode. Got it? Is it clear for all of you? Mr. Karthik? Pistillode. Estivation, you are again asking the same. Mode of arrangement of sepals or petals in the flower. Simply remember that. Junior Itachi. So, mode of arrangement of sepals or petals in the flower. Sepals or petals arrangement method. Okay? Okay, next. Ramya Anandavarapu. Okay. Sandeep Geddamuri is already NCERT books are printed. Okay. Is it printed? I'll inquire today, because I'm going outside. I'm going to check whether 26, 27 edition has come or not. Then I'll inform you in the next class. In offline classes, Venkata Subbamma. In offline classes, we are going to discuss about placentation, estivation in detail. Each topic requires 1 hour. 1 hour. Okay. So, lot of details we are going to explain you, and will make you perfect to attempt any type of question in the NEET examination. Don't worry. Can you tell the botanical name of Solanum? You are already asking botanical name, madam. Sharanya. You are already asking botanical name itself. Solanum melangina is brinjal. Solanum tuberosum, potato. Solanum lycopessicans, tomato. Understood? Okay. Yeah. Yes, I'll inform them. Okay, don't worry, Junior Itachi. Thank you and bye to everyone, and we'll meet again on Monday with a fresh topic. Thank you all. Bye. With this, I'm closing this session. Thank you all.